Welcome everyone. In this video, we are going to solve equations involving logarithms. This is the learning outcome for this subtopic. The method to solve equations involving logarithm is by changing in the form of logarithms with same base. So how to change the base? If you still remember in the previous video, we use this formula to change the base. And it is important to memorize this law of logarithms, which are the product rule and the quotient rule. Question 1 is solving these two equations. If you look at these equations, they are in index form. However, we had to use logarithms to solve it. For question 1a, we want to solve 5 to the power of x equals to 10. We cannot change 10 to base 5, so we had to use logarithm to solve this. By taking log both sides, we can apply the power rule where we transfer x to the front of the log. Then we can solve for x. The answer can be expressed in three significant figures. For question 1b, we divide both sides by 5 first so that only the index on the left side, and we get this equation. By taking log both sides, we can use the power rule law to transfer x to the front of log. Then we can solve for x and leave the answer in three significant figures. For this question, we can directly take log both sides and apply the power rule. Expand the left side, then rearrange the terms so that those terms with x are on the left side. Then factorize the x and solve for x. In fact, we can also state the final answer up to 4 decimal places. This question has two logarithms with different base. So, change log base 4 to log base 2 first. The denominator log base 2 of 4 can be simplified to 2. So we have this new equation. We can cancel out the 2 and we get this equation. Rearrange it so that both logarithms are on the same side. Then we can apply the quotient rule and express it as a single log. This log form must be changed to index form. Then only we can solve for x. You can make sure that this answer satisfies the equation by substitute the value of x into the equation, but it is not necessarily to show the working solution. This question also has two logarithms with two different bases, but this time around, one of the base is a variable x. So it is better to change log base x to log base 3. Then the equation becomes like this. Now that we have two log with the same base, so we can let log base 3 of x equals to y, so that this equation becomes more easier to solve when it turns to variable y. By multiplying both sides by y, we get a quadratic equation in terms of y. Then factorize it and we get the values for y. Now we had to change it back to log base 3 of x to get the values of x. Then by changing this log form to index form, we get the answers for x. This question has two logarithms as well, but this time both are of the same base, which is base e. Remember, Ln is a natural logarithm, which means log base e. Rearrange this equation so that both of the ln are on the same side. Since both are ln to x, so we can directly subtract it. Since ln is log base e, so this is how we change it to index form, where the base of logarithm becomes the base of index number. Then solve for x. You can state the final answer in terms of exponent or decimal number. Please submit this exercise to your lecturer before class ended. Thank you.